È già
Vai.
Okay. Okay. Do you hear me? Okay. Some months ago, AWS reached out to us, asking if we could share on this stage our experience of building the data platform. We panicked. We panicked because I don't know if it is the same for you, but in our case, we have always the impression of being so busy with ongoing activities from supporting regular business to modernizing IT infrastructure that we never really paused to verify if we had something ready to share to the public. But at that day, we did. And we noticed that we had built already so much on the data platform, and that so many other companies out there were about to embark on the same journey, that we actually realized we have a valuable story to tell. My name is Davide Genini, IT Data Asset and Delivery Lead at Alpiq, and today, together with Antonio, the most expert of our data engineers, and Alessandra, Solution Architect from AWS, we are here to tell you that story, the story of Alpiq's journey into the data platform. By sharing with you our initial situation, how we implemented it, and how this is helping us. And hopefully this can inspire and support you in the same journey. And we will do that with the use of 3 business cases. But let's start from who we are. We are Alpiq, a Swiss company whose main activities are power production, energy trading, and sales. We have a long experience in Switzerland, especially in the operation of hydraulic power plants. But throughout the years, we have been expanding our production capacity with nuclear power plants, hydrogen production, various types of thermal assets, and of course, we have been growing also our renewable portfolios with solar panels, wind farms, etc. Our numbers. We are among the top 3 energy producers in Switzerland per capacity installed, with 5.7 terawatt. And we are a quite profitable company with almost 1 billion francs of EBITDA achieved in 2024. We count on 1,300 employees spread all over Europe, even though the majority of them is located in Switzerland, in the offices in Olten and Lausanne, where our headquarters are. But who is speaking to you today? Myself, I am part of the IT team that is leading the transformation into the data platform by sharing the word to the cosmos of the business users. Antonio, being part of the team that is actually implementing the solution, is the best spokesperson to share the technical secrets behind it. And Alessandra, from AWS, is our guidance for the best tools and services that can help us in this journey. Let's look at our stories, our story. Like all stories, also ours starts from a problem. Ours from some problems. And the first of them is summarized by these 2 numbers that we see here. You already know the number of employees. You now see the number of applications that we needed to handle. If you do the math, you can easily see that we practically had 1 application per employee, which is an outstanding negative number. And in addition to that, these 1,000 applications needed to be handled by around 150 IT employees, which means that each of them, on average, needed to manage 7, 8 different applications. On top of that, we need to handle 3 billion transactions per day, which sum up to almost 2 petabytes of data storage, coming from 30 different types of sources. And for all this, only for the data storage, we spent 20% of the IT budget, which is another outstanding negative number. And these 2 numbers are only the tips of the iceberg of all the challenges that we needed to face on a daily basis. For the sake of the exercise, we have summarized this in 3 groups: data, data engineering, and business team related. Regarding the data challenges, we summarized here the 4 main impactful challenges: data silos, lack of data quality, lack of governance, and the problems with the uniqueness of source of truth. Regarding the data engineering challenges, for us, those meant the challenges related to the tools and the technologies that we use to handle the data. And here we had issues related to infrastructure management, the fragmented technology stack, and scalability issues. And then business team challenges related more to the organization and the operational activities. So here we had problems with the lack of self-service, lack of self-service capabilities, and in general, problems at respecting our internal SLAs. If you look at this, the scenario looked dramatic. But let's be honest, who here has never faced any of these issues? In our case, these challenges were causing some consequences that you can easily imagine. The first one was that we had a centralized data team that was practically a bottleneck for any data-related initiative. And then, again, this data team, the members of this data team, needed to be a sort of Swiss Army knife of knowledge to handle all the applications they needed to handle in terms of technical knowledge, business knowledge, etc., which is impossible. And then we were busy in frequent and long troubleshooting sessions. Frequent because you can imagine, just because of the lack of data governance, that was a root cause of many problems. And then long because of the fragmented technology stack that forced us to have multiple people involved anytime that we needed to troubleshoot a problem. And then lack of data quality automatically means inconsistent output results. Garbage in, garbage out. So overall, given all these issues that were quite time-consuming, there was no really room for a proper innovation strategy. In a nutshell, we were always in firefighting mode. To tackle this, we said we need to go through a fundamental revolution, encompassing culture, people, technology, and process. Culture, because we needed business leaders and IT leaders to share the same vision. Process, to make sure that data were put at the core of our ecosystem. Technology, to select the best tools and services available to drive this revolution. And finally, people, to organize ourselves in more efficient data product teams. That's where our journey started. That's where we made the decision of building our data platform.
I guess many of you are already familiar with this image. This is the classic representation of data mesh principles. As you've seen before, when we looked at our situation at Alpiq, we found plenty of challenges that made us slower, less agile, and even led to missed SLAs. We realized we needed a different approach, and this is where the data mesh principles fit perfectly. First, domain ownership. Instead of one central bottleneck, each domain owns its own data, with clear boundaries and responsibilities. Second, data as a product. Not just raw tables dumped into a warehouse, but products that are designed, maintained, and delivered with a consumer mindset. Third, a self-service platform, a backbone that is domain agnostic, giving every team the same set of capabilities so they can innovate without waiting on central IT. And finally, federated governance, policies and standards that apply everywhere, but automated and enforced in a way that doesn't slow teams down. These principles were not just theory for us. They were the exact answers to our data engineering and business challenges. And data mesh became the backbone of our data platform. But now, let's have a look at the evolution of our platform. You will see how it evolved in all the main pillars, with the darker color representing increasing maturity over time. We begin with onboarding and modalities. Here, the focus is making it easy for teams to provision environments and data products, and on providing multiple ingestion patterns. These are the foundational capabilities every domain needs to get started quickly. Next, we have marketplace and governance, and this is where the data really becomes a product. Products are published into a catalog, made discoverable, and governed through access models and quality frameworks. Then we have consume, infrastructure, and operate. And this is about enabling self-service consumption, providing observability and monitoring, managing costs and SLAs, while keeping everything secure and compliant. These pillars make the platform usable and reliable at scale, day to day. And finally, data teams. With all this capability in place, our platform supports high-value use cases like real-time trading, sustainability reporting, and risk management. The key takeaway is that all of these areas are advancing in parallel, each step adding maturity. And together, they ensure that the platform develops in a balanced and business-driven way. After this, we will go to our architecture. Here, you will see the blueprint of our data platform. A lot of boxes, but let me walk you through it from left to right. We start from our sources. ERP system, operational databases, IoT devices, and external APIs. And that's our raw material. These flow into our ingestion layer, which supports CDC, batch ingestion, and real-time streaming. Because in energy trading, some data arrives in daily batches, while other data, like market signals, need to be processed instantly. Once ingested, everything passes through the self-service platform core. And here is where the magic happens. We enforce data quality, access control, and privacy. We provide metadata and discovery through catalogs and API management, and we enable processing and analytics with SQL, Spark, and streaming. After that, we store it in a way that is flexible and reliable. On the right, we are consumers that can take this data and use it in many forms: dashboard, API, AI models, and custom application. The big picture here is simple. Get data in, govern it, process it, and make it consumable, while making everything repeatable, self-service, and secure. I know I'm repeating these terms many times during this presentation, but it's just to highlight that they are important in order to show what is the value we want to add to our business. And this was the conceptual blueprint, but let's see what we produced in terms of actual technologies. At the core, we are leveraging a broad set of AWS native services like S3 and EKS. They give us scalability, automation, and integration right out of the box. We use AWS for ingestion and the foundation of our infrastructure. On top of that, we integrate best-in-class external tools that complements AWS. As an example, we have Snowflake as our analytical warehouse because it gives us strong performance and flexibility. We rely on dbt to manage data transformation in a way that is controlled, version controlled, and transparent. And we use some visualization and app frameworks like QuickSight and Streamlit in order to bring the data closer to the business. All of this is tied together with CI/CD pipelines and monitoring. Tools like DataHubs.live and Datadog, they made sure that the platform is not just a patchwork of tools, but one coherent system. The important point here is not about choosing AWS or external tools. It's about combining them in a smart way. AWS is our backbone, and the other tools enhance it. And together, they form one integrated platform that supports our business needs end-to-end. But technology is only half of the story. What really makes this work is how teams operate around it. Because technology alone doesn't deliver value. It's how people and processes work together that really makes the difference. On the left, we start with our data products team. Each business domain, whether it's trading, finance, or sustainability, has its own team that produce and own data products. They are the closest to the business, so they know what's valuable and what questions need to be answered. At the bottom, we have our platform team, who provide the infrastructure, automation, and tools. and the governance team, who define standards and enforce them through streamlined processes. Finally, on the right, consumers teams. These are the people who take the trusted data and use it to deliver business value. Whether it's real-time trading models, dashboards, or advanced analytics. Together, this operated model ensures that data products can be delivered at scale, consistently, and with confidence. But now, what does it look like for a developer or a consumer in practice? This slide will show you the journey of a data product team. On the left, we started with the two main roles, developers and administrators. They don't work manually. Everything is done through CI/CD pipelines configured with YAML file. That means consistency and automation. As data platform team, we provided a set of reusable components in order to help them in their development journey. Components such as creating Iceberg table, managing Kafka topics, or provisioning API gateways. All of this lands in our data lake, built on S3 and Iceberg. And there is where the data becomes structured and governed data products. Let's move to the right for the consumer side. We have the data catalog, powered by data.world, that acts as a marketplace, and is where it is what makes the data discoverable and transparent. No more guessing on what's inside the dataset. On the bottom, query engines like Athena and Snowflake make the data instantly accessible. The pipeline, the whole pipeline from left to right, is automated and scalable, and that's what makes our platform scalable for multiple domains.
We said that one of our main activities as a company is power production, and that relates a lot to our mission of securing the energy supply. Who here owns an electric car? Can you please raise your hand? Even hybrid is fine. Okay. Can you please keep your hand up if you charge your car the majority of time overnight? Okay, good. Not too many. You can lower it. I'll explain. As you know, in the recent years, there has been a strong expansion of energy production from renewable sources, which is very good, very positive. However, like all sources, they come with some constraints or downsides. Let's take solar panels. Solar panels, they produce energy only during the day, especially only during sunny days. So that means for those of us that are charging the cars overnight, we are not using energy from solar panels. But there is nothing wrong with that. What I'm trying to say is that renewable energies contribute a lot to the energy supply, but also to its unpredictability. They increase the fluctuations on the power grid and on the market. And that's where batteries come into play, because batteries allow you to accumulate energy and release it when you need it, like our power banks. And that means that thanks to batteries, we can indeed charge our cars overnight. And that brings us to BESS. BESS is the acronym with which batteries are identified in the sector. It stands for Battery Energy Storage Systems. And this technology is the subject of our first two business cases, where we had a project divided into two phases. Day one, phase one, day two, phase two, where the data platform helped us gathering data from different sources and provide a standardized output. Alpiq is investing in BESS. And here we see the images of the project of the BESS facility that has been built in Finland. But what is a good strategy to decide when to accumulate or release energy from a battery? One option could be to look at the past and forecast the future. But to look at the past, we need data. Which data? Data coming from the grid or the market, which means capacities, frequencies, prices, volumes, etc. And that's exactly why BESS Day 1 started. The objective of the project was to gather market data and grid data from our facilities, especially in Finland, and then provide standardized output to the users. And be careful, in Day 1, we are not yet talking about ingesting battery data, only grid and market data. For every product, the first requirement is to build a product canvas. The product canvas is a framework used by cross-functional teams to understand, design, and document a data product from a holistic perspective. Here, we are looking at the product canvas of Best Day 1. As you can see, there were 3 sources in this batching modality, 2 external and 1 internal. The 2 externals are represented by Fingrid, the Finnish transmission system operator, and the other one is Nord Pool, the European Power Exchange, which were providing grid and market data via REST APIs. And then there is a third source, internal, named here Volume Metis, after our internal system, Metis, which is gathering data from different sources, where Volue is one of them. And here the integration is happening via files uploaded on S3 buckets. Then data move to the data platform. And since we apply an ELT approach, the raw layer is practically a mirror of the data coming from the sources. Then they are pushed to the transformation layer, where they get historized, versioned, standardized in terms of units of measure and other standards. And eventually they are pushed to the access or data product layer, where they are finally made consumable. And here the consumption is represented by 3 output ports. An API, meaning that users could call the data via this option or integrate other systems. Iceberg tables for direct querying. And finally, BI, meaning that we gave the possibility of attaching reporting tools to the data.
Here you will see a small representation of the ELT pattern that powers our pipelines: extract, load, and transform. First, we pull the data from various sources, databases, API, external feeds, and load it directly into our platform, keeping the raw data always accessible for traceability and reuse. Only then, we transform the data within the platform, cleaning and enriching it, using scalable cloud resources. This ELT approach keeps our process flexible and trustworthy, ensuring every dataset is ready for analytics once it's in the platform. And now you will see how we implemented the ELT for the best day 1 use case. On the left, we start with our external market data, combined it with the internal data products. The first step is extractions from those systems. We leverage EKS and PyIceberg. After that, we load everything straight to Amazon S3. That's our persistent staging area, a place to land raw data securely and consistently. From there, we move to the transform stage, which happens entirely inside the platform. Historization, where we keep track of changes over time. Structured bus, where we standardize the data format and schema. And finally, we have the curated layer, where the data is clean, governed, and ready for use. At every stage, AWS Glue crawlers update the Glue data catalog, so metadata stay consistent, accurate, and discoverable. On the right, consumers can access the curated product in multiple ways. They can run queries with Athena, visualize with QuickSight, or access the data through APIs exposed via Lambda and Amazon API Gateway. And because this is a production-grade pipeline, we monitor it with Datadog, so we always know its health and performance. The key message here is that raw external market data is turned into curated, trusted products. Traders can then rely on this data for their decision-making processes. Now, I will show you which parts of this pipeline are built using our data platform reusable components. Almost everything that is built and not provisioned at the beginning of the onboarding of data product team is basically done through our data platform components.
The second business case relates to our second core activity as a company, which is energy trading. The subject is still BESS, but this time we're introducing the battery data to the system. Who trades here? I mean, not only energy commodities, I mean in general. Can you raise your hand? Okay, good, thank you. I guess that for trading, you try to stay informed, read the news about the assets, the stocks, the companies on which you trade, right? Then I think that at some point, you need to look at a chart like this one to decide at least the price at which you buy or at which you sell. And I think you wouldn't argue that to draw this chart, you need data. I would add something. For short-term trading, if you do short-term trading, you actually want to add a condition. These data need to be always up to date and refreshed frequently and as soon as possible. And this brings us to Best Day 2, where the objective was building a streaming modality, getting the data from the same sources that we mentioned before, market and grid data, and combine them with the data coming from our batteries, so that our energy traders could make decisions quickly and informed. For this case, we can skip the product canvas because it will be the same as before, with just the addition that the data from the batteries are coming via our internal source.
Building on what Davide said, streaming analytics fundamentally shift our data processing paradigm from batch to real-time processing and analyzing. While batch processing operates on fixed windows of historical data, streaming analytics works on data in motion, with latency often measured in milliseconds or microseconds. For our battery use case, these capabilities are critical. So, what are the essential components for a modern streaming analytics solution? As every data architecture, it starts with sources. And data streams can come from many various origins: sensors, social media, application log, continuously producing semi-structured and unstructured data. These sources feed into the stream ingestion layer, which acts as our entry point for the streaming pipeline. This layer handles critical functions such as back pressure management, and it sends the data straight to the stream storage layer, which serves as our persistent buffer. This layer is also the one in which you want to ensure strict ordering of the data, and it must be fault tolerant. But where does the magic happen? The magic happens into the stream processor layer, which is where complex event processing is actually done. Here we implement stateful operation, windowing function, as well as real-time aggregation. So basically, that's where you enrich your data. And finally, when the data are enriched, they flow to various destinations. And even in this case, we have multiple options. It could be a real-time monitoring system, ML pipelines, analytical databases, downstream application, and so on and so forth. What is really important here, and when you're building your modern streaming analytics solution, is that each component must be designed to handle continuous data flow while maintaining low latency and high throughput, essential characteristics for the use cases such as the one that we're seeing today with Alpiq. Best Day 2. Great. Now I guess that we are all know how a modern streaming analytics solution should look like from the foundation perspective. Let's dive into the architecture. I know David already said quite a few times, but I'm going to be repeating it one more. When it comes to the sources, we have Fingrid and Norpol, two external sources, and then we have Volumetis, that is another data product from Alpiq that provides curated data, including the information on whether the battery is charged or not. And this is the information that traders would probably use for deciding whether to sell or buy. All external data are ingested through an internet gateway and are routed via an application load balancer to an application that is hosted on Fargate on private subnet. But as you might recall from the Canva at the beginning, the data product is actually storing data on an S3 bucket. This is the reason why they are ingested through an S3 endpoint. The application acts as a producer and streams the data through the storage layer. As storage layer, we have decided to use Amazon Managed Streaming for Apache Kafka. The name is super long. I'll call it MSK from now on. I hope it's fine. MSK is an AWS streaming data service that manages Apache Kafka application, infrastructure, and operations, making it easy for developer to run Apache Kafka application on AWS. This icon that you see here is actually a reusable component that we have been building with the data platform team. And one of the decisions that we had to take was about which type of cluster to use. MSK, in fact, provide two types of cluster, provision and serverless. We decided to go for the serverless one as it allows you to run application without having to provision, configure, or optimize your cluster. So this is allowing you to cut the cost, but in the same time, this is a very early stage data platform, so many more data products, real-time streaming requirement might be coming. But we said that the magic is happening in the streaming processing layer. So for the streaming processing, we adopted or opted for Apache Flink. Apache Flink is a robust open source framework that handles high throughput, low latency, and complex stateful computation, both for real-time and batch data streams. This is also, as you might know, the de facto standard for streaming processing. And even in this case, we decided to leverage a managed service from AWS, which is called Amazon Managed Service for Apache Flink. We're very long with names, I'm sorry. But even in this case, it allows developers to easily manage and handle Apache Flink application. Here it's where we do the streaming, or Alpiq is doing the streaming ETL, aggregating and enriching the data. The data then flow to two different destinations. On one side, we have a separate Kafka topic on our MSK cluster that streams the data to other internal Alpiq services such that the traders can do their job. And then they are also sent to an S3 bucket as curated data that will be leveraged potentially by other data products or could be used for analytics, as we see here, through Athena. This architecture showcases how the components that we were discussing before as high-level components are actually implemented in a real-world scenario as best they do. You have already seen me talking about it, about reusable component. Antonio has been speaking about it for best day one. Even in this case, most of the elements that you see in this architecture are reusable component that has been built by the data platform team.
Our last business case brings us to the third core area of activity of Alpiq, which is sales. And it does it in combination with artificial intelligence. Let's see how. The business case was about ingesting data from the different transmission system operators in Spain to build a grid map like the one that we are looking at of the peninsula with the capacities and the different location of the various delivery points. The interesting aspect of this comes especially from the providers and the way they provide the data. Because these providers are used to frequently change the format of the data they provide by adding new columns, removing existing columns, and doing other changes on the data dictionary. This might sound simple, but in our case, that meant always to open the database, change the database, open a pipeline, change the pipeline, open a report, change the report, and eventually update also the documentation. All this was a quite tedious procedure that we wanted to tackle with this project. But before going into the technical details of how we did it, here we can see some of the motivations why we decided to do it, especially in relation with the challenges around our visualization layer. The first one was that we actually have business users that are willing to build the dashboards by themselves, but they actually lack the technical knowledge to do it. And given that, the pressure on the data team was again increasing because they needed to take care also of this. And given also the large number of dashboards and reports that we needed to build, we actually were not able to have a standardized approach, consistent approach on building them. And of course, all the process was fully manual. The development was manually done. And last, I think that some of you might agree, documenting is a bit tedious. Nobody really wants to do it, so documentation was manual and often incomplete. So this made us thinking, let's try to tackle, if not all, at least part of these challenges with the data platform in combination with artificial intelligence.
While thinking about leveraging AI for solving all these challenges, at AWS, we announced the release of Amazon Q in QuickSight in the Frankfurt region, which is actually the primary AWS region used by Alpiq. So, along with Antonio, we decided to work on a new approach for schema management and visualization. This time I'm providing you the whole architecture because it's a little bit simple. We've implemented a solution that automatically detects changes in the schema. So when a new column is coming or an existing one is changing, the system immediately identifies it and calls a model via light LLM. Sorry. This model interprets the schema changes, update the semantic model, and re-upload the updated version. This version then is up to date into the visualization system so that the traders and the end users don't really have to take care of that. You can see here that there are two accounts in this architecture. The reason is, as with many other companies, also Alpiq is starting their GenAI journey. And one of the things that they wanted to ensure is to have a GenAI platform that provides flexibility to use different models coming from different providers. That's the reason why we have two separate environments, one for data, one for the GenAI platform. And into the GenAI platform, we have a light LLM gateway to get access to the models that are coming from different providers and that are right for the different use cases. For this specific use case, we decided to leverage a few models that you can find in the Amazon Bedrock Marketplace. Now, we have been looking at the upper part of the architecture, but let's focus for a moment on the end user. Thanks to this solution, and thanks to Q in QuickSight and its topics, traders and end consumers can now benefit from always up-to-date visualization and the ability to interact with Alpiq complex grid data and pricing through natural language queries. This means that our end consumers, or Alpiq end consumers, can actually just ask natural language questions, and Q will find the right data set, find the right relationship, and provide the best visualization to the end users, making it easy for them and reducing the technical debt knowledge that Davide was mentioning before. This solution is far from finished. We plan also to enhance it by, for example, adding specific Alpiq knowledge to define then description to the different schema components. But what is very relevant of this architecture is actually that it is, again, done with reusable components. But it's not all. This solution, so schema management and visualization, is not just something that is related to the grid models. It is a concept that can be abstracted and that could be reused for many different data products. That's the reason why now it is part of the reusable components that Alpiq is providing to the different data products team within the organization.
This brings us to the conclusions of our session. First of all, specifically to the business cases we shared, thanks to the data platform, we collected some relevant advantages. For example, in the case of the batteries, we were able to historize large data sets coming from different sources and different types of data. And then, thanks to smaller teams and more highly focused, thanks to reusable components, and thanks to more modern technologies, we were able to reduce the time to delivery. And we estimated the reduction to be by 60%. And on top of that, thanks to the introduction of better data quality controls, better governance, and the prevention of duplicates, we were able to reduce also the infrastructure costs. And for these cases, we estimated by 75%. In relation to the grid model use case, again, we took advantage of reusable components. But in addition, we were able to automate the update of the data dictionary and provide more user-friendly options for dashboarding to users. To recap, being an energy company, we rely a lot on data. And if you remember, these were the challenges that we had at the beginning of our journey. We said that we needed a revolution to tackle these problems. A revolution encompassing culture, process, people, and technology. And we wanted to do it via building our data platform. If we look at the different challenges in the data area, for example, we broke the data silos at the moment we introduced data products, because they need to be findable, shareable, they need to interact between each other, so the data silos were broken. The other problems of data quality, governance, and unique source of truth were, or at least are getting tackled by the fact that the data platform imposes automatically controls on all these areas, by definition. And then, going to the data engineering challenges, all the problems of infrastructure, the fragmented technology stack, and the scalability issues are getting tackled, again, by the modalities that Antonia and Alessandra explained us today. And last, the problems of organization and operational. If you think about lack of self-service and agility, those are getting tackled by the introduction of the data mesh approach in combination with artificial intelligence. And naturally, then, our scores against SLAs are also improving. To summarize, considering where we started, our journey cannot be short. But given the results that we have obtained so far, the data platform is showing to be the right way forward. Thank you.
Done?
Okay.